All right, hello, geometry scholars. Here's your first video for Unit 3. Sorry, Chapter 3. It's Unit 2. But speaking of chapters and units and book and all that kind of stuff, this is going to be a little cleaner than last unit in that we're pretty much just going to do all of Chapter 3 from the book, not leaving a whole lot out. There's a little bit in there from Chapter 1, but it's going to be easier at the end to study for this because it's kind of more self-contained with the book that way. Okay, so this unit is about parallel lines and how you get angles formed by crossing parallel lines with a third line, that kind of stuff. First of all, we haven't really talked about parallel yet. Parallel are lines in the same plane that never intersect. So yeah, it is important that they have to be coplanar because it could be that we're talking about lines that are in different planes that never intersect, and we don't want to call those parallel. More on that on the next page. So just realize that when you say parallel, you are implying that we're talking about coplanar. I think you're familiar with parallel lines look like, train tracks, that kind of thing. So that's not a new term. Not only can lines be parallel, but planes can also be parallel. This plane A appears to be parallel to plane B, meaning they will never intersect, like the floor and the ceiling. Okay, so here's a better idea of how lines could be not parallel and not coplanar. Here we go. So lines that are skew. So I'll just tell you at this point what a pair of skew lines look like. HF, okay, so it's like the back top edge of this cube. HF we would say would be parallel to GE. It would be parallel to DC, and HF is parallel to AB. Those lines are kind of even with each other in some way, like even HF and AB. They're going the same direction. You could draw a plane. You could imagine a plane that cuts through HF and AB. But HF is not parallel to BC. HF and BC are not parallel, but they also don't intersect. They're going to miss each other. I think of it as like roads at an intersection where there's an overpass, like there's a lot of those in Singapore, where you have one road. Here, let me draw this. You have one road, or highway, and then you have another road that has a bridge that kind of goes over it and doesn't really look like that, but it's a straight line, and there's another straight line underneath it, but they don't have an intersection. There's no place where you're standing on the road and you're standing in both places because there's a bridge and one's kind of over the other. Like HF and BC, they don't intersect. HF is back here, BC is up here. If you kind of stood in the right place, you'd see where they kind of cross each other, but there's space between. There's no points that they have in common. So it's hard to do this. I'm getting better. BC, just a second. Sorry about that. I had to take a major pause there. All right. So BC is skewed to HF. Another one that would be skewed with HF would be BE. This actually looks more like that underpass idea. Like HF is the highway that goes over, and BE is the road that goes under. They're never going to cross, but they're not parallel because they're not coplanar. So let's add that to the list here. I'll write all the skew ones here. Gosh, lots of them are skew. All right, BE. What else? Pause, I'll do it so we can save time on video. Well, I guess there's only two more, GA and AD. Any other line on that is either going to intersect HF or be coplanar and be parallel. A plane parallel to AHG. All right, AHG is the plane. AHG, that's this sort of left wall of the cube there. A parallel plane to that would, I guess, just have to be the right wall. So remember when we label planes, people miss this on the test. You just need 3 letters. I don't need a symbol on top. I don't need 4 letters, just 3. All right, probably looks confusing now. I don't want that to stay there. All right, lines that intersect CB. Well, on this, it looks like we're going to have the point C in them or have the point B in them. So CD, great. CD intersects CB. Oh, something. How about at B? How about BE? Sure. And there's a bunch more. Looks like there's 3 that hit at C and 3 that hit at D. Okay. All right. Next term, transversal. Transversal is something. It's a type of line. We call it a transversal. Trans kind of means cross, like a train. And you can think of these as train tracks. The transversal is the one that goes kind of averse to that. I don't know if that's the right use of that word or not. But anyway, transversal crosses the other two. It says a line that intersects 2 or more coplanar lines in different points. So if you had 2 lines like this that already crossed, and then you had a third line that crosses both like that, that's not a transversal. It has to make two new points of intersection. Now the first two lines don't have to be parallel. They could actually cross. Like these are not parallel. I extend that one. That's definitely not parallel. I could have a third one here, crosses both, and it's actually a transversal. If you look carefully at this picture, they're actually all three are transversal because they all cross two other lines. We don't do this one very much. Like it's not usually helpful to call that a transversal in that sense, but it can be possible. Just because there's a transversal doesn't mean these have to be parallel. We do lots of problems where they give you a picture like this, and then they give you some angles, and you got to try to figure out if they're parallel or not, and they want to still call this a transversal. So it doesn't mean they're parallel, but that's usually what we see. Usually it's a picture like this. All right, so here's the terms. Here they come. Corresponding, consecutive interior, alternate interior, alternate exterior. Before this, we had names for angles that were related to each other in the position in the picture, like vertical angles. Vertical angles were like this. We had linear pair angles. Linear pair angles were like this angle, and this angle. These are terms like that. They tell you how angles are arranged and kind of juxtaposed against each other. This one's called corresponding angles. Corresponding angles, and he's got these marked here, 2 and 6. Great. 2 and 6 are corresponding angles. I think one way we'll go through these terms again. I think one way to think of the term corresponding is it's like they're doing the same job in two locations. It corresponds. Like when you write letters back and forth to people. Both these angles are kind of in the northeast corner. So that's what we call corresponding. You could also say 3 and 7 are corresponding because they're both in like the lower left corner. So they're in the same position but at different intersections. Angle 1 and angle 5 are corresponding. All right, consecutive interior. All right, interior is this zone in here. This is the interior between the two possibly parallel lines. So when they say interior, that's a different way we've used that term. Interior is in this zone, so we're only talking about angles 3, 4, 5, or 6. Consecutive interior angles would be angles on the same side of the transversal inside the same, on the interior here. So angles 4 and 6 are consecutive interior. Angles, I don't love this term, so bear with me here. 3 and 5 are consecutive interior. Believe it or not, they don't let 5 and 6 be called consecutive interior angles. So just file that away. It's got to be like two angles that make a corner like this, like 3 and 5 or 4 and 6. Alternate interior, okay, so interior again is this part in the middle. Alternate interior means we have one on one side of the transversal and one on the other side of the transversal, like 3 and 6. Another pair of alternate interior would be 5 and 4. They are alternate interior to each other. Yeah, you can't say 3 and 4 for alternate interior. They have to be at different intersections. All these are for pairs of angles. You'll notice there's one at one intersection and one at the other. There's going to be a 1 through 4, and there's going to be a 5 through 8 in all of these situations. These new terms today. Alternate exterior, okay, so I need one from up here, one from here. Alternate because they're on the opposite sides of this thing, so like 1. And exterior because it's outside, it's outside the zone of the parallel lines. So if this was interior in here, exterior is on the outside. So 1, 2, 7, 8 are exterior angles. 1 and 8 would be on alternate sides of the transversal. And just like 2 and 7 will also be on alternate sides of the transversal. So all these words kind of play off each other. Interior, of course, means in the middle there. Exterior means outside. Alternate means we're talking about opposite sides of the transversal. Consecutive means really we're on the same side. I wish they would have said same side. Our last book called this same side. You know what? I'm going to write that on here. I'm just going to write same side right there because the other book called it same side. A couple books I've used called those same side. You might hear me say that accidentally. All right, here's the book's version of all those. It's the same exact information. It's just written out bookwise. Here's a way to remember those angles. These angles are fun. And on your page, I drew these in. The angles that make a corresponding set kind of look like the angles of the letter F. The angles that make a consecutive interior set kind of look like the angles of the letter U. I'm going to mark this with 2 arcs. You'll see why in a minute. And alternate interiors make angles that look like the angles of a N. Exterior, I'll just change colors here. Exterior is on the same picture, but exterior, of course, would be outside the N. So you see all those there. And it spells fun. How cool is that? All right. Example 2. Let's do all these. If you know things are parallel. Oh, wait, did it say that back on here? Yeah, here's the theorem. I didn't mean to skip this. On here, it says not only what these terms are, alternate interior, consecutive, all that stuff, but it tells us the so what, like who would care about this? All right, first of all, these are parallel. When they mark it with this pink arrow that's kind of in the middle of the line, and they mark a corresponding set like this, see like these two and these two, it means those guys are parallel. It's kind of like on congruent segments, we used to do stuff like this. If we had two congruent segments, we want to mark them congruent, we could do stuff like that. These are those types of marks, but they're little arrowheads. Arrowheads in the middle of the line signify parallel. So if lines are parallel, some of this stuff we're going to know about. It turns out that corresponding angles are congruent, so 1 and 3 would be congruent if the lines are parallel, just like 2 and 4, or 6 and 8, or 7 and 5. Alternate interior angles, like 1 and 3, also congruent. Alternate exterior, like 6 and 8, also congruent. The thing that's weird here, that one of these things not like the others, is consecutive interior. Those are supplementary. 1 and 2 consecutive interiors are supplementary. 1 and 3 are congruent, because they're alternate interior. 1 and 2 are supplementary. If you think about that, it's not hard to prove that. 2 and 3 are supplementary. If 3 and 1 are congruent, then 2 and 1 better be supplementary. So that's sort of why. But the name for that is consecutive interior. All right, let's fill these out. So if they tell me this angle is 130, I can start filling in a whole bunch of angles really fast. The hard part is to know why, because you're going to have to name them. It's really fun to just go ahead and start writing in angles and numbers because you feel really accomplished doing that. But there's going to be things you have to name. This, of course, is 130 because 6 is a vertical angle. Wait, I'm not going to write these in here. Because it's vertical there. And if this is a linear pair here, the 130 and angle 5 has to be 50 because of linear pair. And 7 and 5 are vertical, so that's another 50. Notice what happens here is we just get 2 of the same number, 2 copies of each. Because of linear pair and vertical. Now what's nice about this, if this is parallel, here's another parallel marking thing. This is how GSP does it. This is how you'll see it in other books too. And I'll draw on the board this way, it's easier to draw. These 4 we can just kind of copy paste up in this section. Why? Well, 50 is corresponding with 1. That's corresponding. 2 corresponds with 130. So really all we need here is corresponding angles, because they've all got their corresponding partner sort of down here. The one that's not marked on here is angle 8, but look, if that's 90, and these are parallel, that means this is going to have to be 90 corresponding, and I have vertical there, so of course that's also going to have to be 90. There's a lot more interesting, examples of this we'll do in class. Here's a better one. All right, these guys are parallel. If this one here is parallel to this one over here, x and 101 have to be equal because of corresponding, and look again, because the other 101. The other pair is also parallel. This x has to correspond with that one down there. Well, then you just have to divide by 2 to figure this out. And the other one, this quadrilateral down here, I know those are parallel. B, this angle at B and this angle F have to be congruent. Now, they're not corresponding. They're congruent because they are alternate interior angles. They make the N shape. And it looks more like a backwards Z here, but this is the same kind of positioning as we were looking at with the N with alternate interior. Let me solve that. I'm almost out of time. Again, I know those angles are equal because of alternate interior. 3x plus 20 equals x plus 50. Solve that for x. That's wonderful. Since I know that's 15, I know these angles are actually 65. And can I find 2y minus 5? Actually, I can't. There's nothing that tells me how to find 2y minus 5. I could call these same side interior, what was that other word? Consecutive interior. I have the U shape here. But I would have had to know that this thing was parallel to this. And they didn't tell me, so it's a trick question. Oh, don't you love it? All right, so that's the end of the video. After this on your sheet, I know it says to do some stuff out of the book. That's not for the B3 block. That's for my other classes. You just need to watch this video and fill out this worksheet. Thanks for watching. See you on Tuesday.